Imagine waking up tomorrow to robots that can think, learn, and move just like humans. Not in 20 years, but right now. At NVIDIA's latest GTC event, Jensen Huang didn't just show us the future of robotics. He brought it on stage and let it walk around. Today, we're diving deep into how NVIDIA just changed everything we thought we knew about robots. And trust me, what Disney and NVIDIA doing with this technology will blow your mind. Today, we're talking about something that feels straight out of science fiction. NVIDIA's groundbreaking announcements from their GTC 2025 event that are completely reshaping how robots will work in our world. Whether you're a robotics engineer or just someone who wants to know how AI will change your life in the next few years, you're going to want to stick around. But before we jump in, if you enjoy staying ahead of the tech curve, smash that subscribe button and hit the bell so you don't miss out on future videos like this one. Now, let's dive into the robot revolution. The shift in computing. Let's start with what Jensen Huang, NVIDIA's leather jacket-clad CEO, emphasized at the beginning of his nearly 3-hour keynote. We're not just seeing new products, we're witnessing a fundamental shift in how computing works. For decades, computers have worked on what Jensen calls a retrieval model. We create content, store it, and then fetch what we need. But now AI understands content, knows what we're asking, and generates answers rather than just retrieving data. Jensen described this new paradigm as agentic AI, artificial intelligence that has agency, can understand, reason, plan, and take action. It can use tools. This isn't just a faster computer. It's a completely different approach to computing. And to meet the demand from companies and consumers, Jensen estimates we might need $1 trillion worth of new data centers. Let that sink in. $1 trillion. General-purpose computing has run its course, he said, and we're at the tipping point of a platform shift from hand-coded software to AI. What does this mean for you and me? The infrastructure being built now is essentially AI factories with one job: generating tokens that become music, words, videos, and research. This is the foundation everything else we'll talk about today is built on. Meet Groot N1, the robot brain. Now, let's get to the star of the show. NVIDIA Isaac GR00T N1. This isn't just another robot control system. It's the world's first open, fully customizable foundation model for generalized humanoid reasoning and skills. What makes GR00T N1 revolutionary is its dual system architecture, which is actually inspired by how human brains work. It has what NVIDIA calls System 1, a fast-thinking action model that works like human reflexes or intuition. Then there's System 2, a slow-thinking model for deliberate, methodical decision-making. System 2 uses a vision language model to reason about its environment and the instructions it receives, then plans actions. System 1 translates these plans into precise, continuous robot movements. The result? Robots that can understand their environment and adapt to it in real time. The most mind-blowing part? GR00T N1 can generalize across common tasks. Whether it's grasping objects, moving things with one or both arms, transferring items between hands, or even performing complex multi-step tasks, it can figure it out without being explicitly programmed for each scenario. During the keynote, Jensen demonstrated 1X's humanoid robot autonomously performing domestic tidying tasks using a post-trained policy built on GR00T N1. This wasn't some pre-programmed demo. The robot was actually understanding its environment and making decisions. And here's the kicker. NVIDIA is making GR00T N1 available now to developers worldwide. It's fully customizable, meaning developers can post-train it with real or synthetic data for their specific humanoid robot or task. Leading humanoid developers like Agility Robotics, Boston Dynamics, Mentee Robotics, and Neuro Robotics already have early access. Jensen's vision is clear. The age of generalist robotics is here. With global labor shortages estimated at more than 50 million people, these technologies could transform industries by creating robots that can adapt to different tasks instead of being programmed for just one specific job. Newton, the physics engine. Now, for robots to move and interact with the real world effectively, they need to understand physics. That's where the new Newton physics engine comes in. And this isn't just an NVIDIA project. It's a collaboration between NVIDIA, Google DeepMind, and surprisingly, Disney Research. Newton is an open-source physics engine built on the NVIDIA Warp framework. It's specifically optimized for robot learning and compatible with simulation frameworks like Google DeepMind's MuJoCo and NVIDIA Isaac Lab. But what does a physics engine actually do? It lets robots learn how to handle complex tasks with greater precision by simulating how objects interact in the real world. This addresses what roboticists call the sim-to-real gap, the difference between how robots perform in simulation versus the real world. Google, DeepMind, and NVIDIA are developing something called MuJoCo Warp, which is expected to accelerate robotics machine learning workloads by more than 70 times. That's not 70%, that's 70 times faster. This is crucial because one of the biggest challenges in robotics is training. Robots need to practice tasks thousands or millions of times to get good at them. In the real world, that would take forever and be incredibly expensive. With these advancements in simulation, robots can gain years of experience in just days or hours. Disney's robotic characters. Now this is where things get really interesting, especially if you're a Star Wars fan. Disney Research will be one of the first to use Newton to advance its robotic character platform that powers next-generation entertainment robots. During Jensen's keynote, Star Wars-inspired BDX Droids actually joined him on stage. These weren't just static props, they were expressive, interactive robots. Kyle Laughlin, Senior Vice President at Walt Disney Imagineering Research and Development, said, "The BDX Droids are just the beginning. We're committed to bringing more characters to life in ways the world hasn't seen before." Think about what this means for theme parks, entertainment, and storytelling. These droids also recently wandered around at SXSW during a presentation called The Future of World Building at Disney. We're looking at a future where your favorite characters don't just exist on screen, they could physically interact with you at Disney parks. This collaboration between Disney Research, NVIDIA, and Google DeepMind aims to create a new generation of robotic characters that are more expressive and engaging than ever before. Disney wants to connect with guests in ways that only they can, and robotics is becoming a key part of that vision. The data challenge and solution. A critical challenge in robotics development is data. To train robots effectively, you need massive, diverse, high-quality datasets, which are incredibly costly and time-consuming to capture. For humanoid robots specifically, real-world human demonstration data is limited by a person's 24-hour day. You can't have humans demonstrating movements non-stop for months on end. NVIDIA's solution? The NVIDIA Isaac GTC blueprint for synthetic manipulation motion generation. Built on Omniverse and NVIDIA Cosmos Transfer World Foundation models, this blueprint lets developers generate exponentially large amounts of synthetic motion data from just a small number of human demonstrations. The results are staggering. Using the first components available for the blueprint, NVIDIA generated 780,000 synthetic trajectories, equivalent to 6,500 hours, or 9 continuous months of human demonstration data, in just 11 hours. When they combined this synthetic data with real data, they improved Groot N1's performance by 40% compared to using only real data. To further equip developers, NVIDIA is releasing the Groot N1 dataset as part of a larger open-source physical AI dataset, now available on Hugging Face. This democratizes access to high-quality training data, potentially accelerating robotics development worldwide. So what does all this mean for the future? We're entering an era where robots won't just be machines programmed for specific tasks. They'll be adaptive, learning systems that can understand their environment and make decisions. From warehouses and factories to hospitals and possibly even our homes, these technologies could transform how we live and work. The collaboration between tech giants like NVIDIA and Google with entertainment pioneers like Disney shows just how broad the applications will be. This isn't just about industrial efficiency, it's about creating new experiences and solving global challenges. The most exciting part? This is happening now. Groot N1 is already available to developers, and the Newton physics engine is expected later this year. The robot revolution isn't coming, it's already here. If you found this breakdown informative, give this video a thumbs up so more people can discover it. I'm genuinely curious. What applications of this technology are you most excited about? Let me know in the comments below. And if you want to stay on the cutting edge of AI and robotics, hit that subscribe button and bell notification. I cover all the major tech developments as they happen, breaking them down so you understand not just what's happening, but why it matters. Thanks for watching, and I'll see you in the next one.